Okay, so question number 2 on your sheet says, zinc metal is placed in aqueous copper 2 sulfide ions, and copper 2 sulfide ions is a single replacement reaction, which can be explained in terms of oxidation and reduction. Okay, so it's saying that it's zinc, zinc metal, so zinc solid, is placed in aqueous copper 2 sulfite, so SuSO4 aqueous. Okay, and it says it's single replacement, which means it should become Cu solid plus ZnSO4 aqueous. Okay, but we know that's not really what it's going to look like. It's really going to look like Zn solid plus Cu2 positive aqueous plus SO4 2, whoops, I didn't need the bracket there, 2 negative aqueous, it was meant for down here, going to Cu solid plus Zn2 positive aqueous plus SO4 2 negative aqueous. All right, so the first question says, what are the products of this reaction? So the products are copper solid and zinc sulfate. 2, what happened to the copper 2 ions as they reacted? The copper 2 ions went from an ion to copper solid. They gained 2 electrons. They were reduced. C, write the half reaction equation showing this. So it would be Cu2 positive aqueous plus 2 electrons going to Cu solid. Balance the half reaction with the appropriate number of electrons. We just did that. What happens to the zinc atom? So the zinc goes from a solid to a 2 positive. It's lost electrons, which means it's being oxidized. Write the half reaction showing the zinc atoms converted to zinc ions, including the appropriate number of electrons. So it would be Zn solid going to Zn2 positive aqueous plus 2 electrons. Which reaction gained electrons? Which one loses? This one gains and gaining electrons, so this one's your reduction. How do I know it gains? They're added on the reactant side. Zinc loses, how do I know? Because they come off on the product side, so this one's oxidation. Does the sulfide ion change during this reaction? No, right? It's SO4 2 negative. It's still SO4 2 negative. What is the substance called that doesn't change? It's called a spectator ion. Okay, so that's your number 2. Number 3 has several different parts, so it says, I wrote A down before we started. For each of the following, write the half reactions, balance each half reaction by balancing the atoms and the charge, then balance the electrons between the equations and write the balanced net ionic equation. So first write it in its dissociated form. So Sn solid plus Cu2 positive aqueous plus NO3 negative going to Cu solid plus Sn2 positive, oh no, that's a 4 positive, and I know that because this is NO3 4. Okay, so that must be 4 positive aqueous plus NO3 negative aqueous. All right, so if we look at first the Sn, it's going from Sn solid to Sn4 positive aqueous. Which side do the electrons need to go on to balance this out? They have to go on the side with the 4 positive, because 4 positive plus 4 negative would give me back 0. So they're going on this side. Looking at the Cu2 positive aqueous is going to Cu solid. Which side do the electrons need to go on? They have to go on the side with the 2 positive, and there has to be 2 of them, so when they add together I get 0 out. Okay, now I can't add these up just yet because I have 4 electrons up here and only 2 down here. So I have to put a 2 in. So my SN's inside the half reaction and my Cu's are balanced. So now I can add them together. So I will have SN solid plus 2 Cu2 positive aqueous, 4 electrons, but it's going to balance out the 4 on the other side. And then I'll have 2 Cu solids plus SN4 positive aqueous. Do a little check, 1 SN, 1 SN, 2 Cus, 2 Cus. Total charge on the reactant side is positive 4, on the product side positive 4. So all is good. Now, but if you looked at number 4, it said classify each half reaction back in number 3 as reduction or oxidation, and then label the oxidizing agent and reducing agent. So while we're on 3A, we may as well do this. This top one is losing electrons because they're on the product side, and losing electrons is oxidation. Copper is gaining electrons, and gaining is reduction. So copper is being reduced, which means it must be the oxidizing agent. Tin is being oxidized, so it must be the reducing agent. So 3 and 4 for A are done. 3B's equation is Br2 positive liquid plus, not positive, just liquid, Ki aqueous going to I2. I have a feeling that's a solid, even though there's no state there. KBr aqueous. Okay, so again, write it in its dissociated form. The Br2 stays together. Potassium will be a positive. Iodine will be a negative. Going to the I2. Oops, I just said it was a solid. Plus K positive aqueous plus Br negative aqueous. Okay, so again, the spectator is going to be the potassium, right? Just like the NO3 up here was. So it's Br is changing and I is changing. So if we do Br2 first, Br2 liquid is going to Br negative. Now there's a 2 here, so I have to put a 2 here. How many electrons do I need to add in to balance it? 2. Which side? I can't add them on the product side this time, because then I'll have 4 negative over here and 0 over here. Have to add them on the reactant side. Okay? This one then is gaining electrons, so this is going to be my reduction half reaction. Now I look at my I, so it's I negative going to I2. Whoops, and this is aqueous, and this I think is solid. So which one do I need to add electrons to? Have to add them to the product side, so that I'll end up with a negative. But wait, I have 2 I's, I only have 1 I. I need to put a 2 here, and now I'm going to add 2 electrons. This guy is losing electrons then, right? He's going from a negative to no charge, so he's losing electrons. This is oxidation. We're going to add these together. I don't need to multiply by anything because there are 2 electrons on either side. So it's going to be Br2 liquid plus 2I negative aqueous going to I2 plus 2Br negative aqueous liquid aqueous. Okay? And then the last step, which one's the oxidizing agent, which one's the reducing agent? Well, Br was being reduced, so it must be the oxidizing agent. And iodine was being oxidized, so it must be the reducing agent. And that